Hello, my name is Ian and I'm going to show you the current build and performance of my Small Balanced Tesla Magnifier. As usual, I have to tell you not to try this yourself unless you really know what you're doing, because these circuits can be lethal. Firstly, I'm going to show you one of the two resonators. This one has a 12-inch by 3-inch toroid as a top load. The winding itself is about 800 turns on a 4-inch tube, and at the bottom you may see I've put a copper ring. This acts as a corona ring and a grading ring for the resonator. I'll now show you the secondary and the primary of the transformer of the magnifier. What you see here is the copper tube making up the primary. There's about 20 turns available. I'm using 8 turns at the moment. You can also see 2 wires coming up as a safety gap of about 6 inches for the magnifier transformer. Inside the primary is a smaller tube containing about 400 turns of 1mm wire for the secondary of the transformer. And then on the right here there's a second resonator exactly the same as the first, and I have about a 1 meter air gap between the two resonators. I'll show you very quickly the outline of the circuit diagram, because it's a fairly standard circuit. I'm not showing all of the filters, fuses, bleed resistors and switches that keep it safe. The circuit is balanced as far as possible to minimise interference and voltages to ground, and to virtually eliminate the need for a high performance RF ground electrode array. So I'm going to stand back now and I'm going to show you what the magnifier can do. So firstly, I'll try and set this camera to show the relevant area. I'm going to move the diagram out of the way. So here we have a 1 meter air gap here between the two resonators, and there are breakout points, one on each toroid. Here we go. Okay, now I'm going to remove the breakout points from the toroids. This will raise the breakout voltage a little, and also the direction will become more random. So here we go. There you go. I noticed a fair amount of sparking on the safety on the secondary, so I'm assuming that means I'm a little out of tune. Before I go, I'll quickly show you some of the components. Here's the Variac. It's a 3 amp Variac, quite standard. Here is the main power board, and so here is the neon transformer itself. 7,000 volts, 50 milliamps. The wiring is, I hope, to a fairly good standard. It's part of the safety is to have wiring that is secure and fixed. So you'll see insulators here, you'll see some filter components which actually provide protection for the transformer. You'll see some safety gaps. There's a gap on the capacitor and a gap on the output bar there, and then the same on the other side because it's balanced. And then here you'll see the spark gap, the main spark gap, which is actually 3 short gaps in series, so each of them is about 2 millimeters. And then finally there's the blower underneath, which provides the air for the spark gap. And also if I look inside the transformer that we looked at earlier, here are the copper windings of the primary. Here are the windings of the secondary inside. I'm not getting that very well, but it's on a 4-inch tube as opposed to a 6-inch tube as it is for the outer. And then in this lower tube you'll see some capacitors, and these are the 2 MMCs, 1 MMC in each tube. I think that's all for now. Thanks very much for watching.